Hi, here we're going to be looking at a quick, hopefully, review of radicals and how they relate to exponents. So radicals would be things involving roots, square roots, cube roots, other kinds of roots. So when we write something like this, the nth root of a, that means the number that you have to raise to the nth power to get a. So some terminology here. The little number that tells you what kind of root it is called the index of the radical. And this radical sign, that's what that's called, the radical sign. And then the name for the thing underneath the radical sign, the number or expression that you're taking a root of, is the radicand. And by the way, the word radical and root, they pretty much mean the same thing. That's why a radish is a root vegetable. So anyway, in something like the cube root or third root of 5, the index would be the 3, and the radicand would be the 5. The fifth root of x plus 1, 5 would be the index, x plus 1 would be the radicand. So this would mean the number that you have to raise to the fifth power to end up with x plus 1. And then for the square root of 2, the index is 2. And when we talk about square roots where the index is 2, we usually don't write the little 2 because square roots are by far the most common kind of root that's used most often. So when you write the radical sign without the little number indicating the index, it means the square root, the 2th root. And of course here the radicand happens to also be 2. So the square root of 2 means the number that you have to square to get 2. And little nitpick here, the nth root of a really means what we call the principal nth root of a. That is, there might be more than one number that we can raise to the nth power and end up with a, and in that case, we specifically want the one that's positive. For example, the fourth root of 625 is 5, because 5 is the number that you have to raise to the fourth power to end up with 625. But 5 is actually not the only number that works that way. If you took negative 5 and raised it to the fourth power, negative times negative times negative times negative would come out positive. So negative 5 is a fourth root of 625, but it's just not the principal fourth root of 625. So that's the one we mean if we just write something like this, the fourth root of 625. Okay, if you look at this little chart here, you can see some examples of squares, and then if you look at it from the other direction, square roots. So like 5 squared is 25, so the square root of 25 is 5. 7 squared is 49, so the square root of 49 is 7. And look at what happens with variables. X squared is x squared, so the square root of x squared, the thing that you have to square to get x squared, would be x. X squared squared is x to the fourth, so the square root of x to the fourth would be x squared. X to the third squared, x times x times x times another x times x times x is x to the sixth. So the square root of x to the sixth would be x to the third, and so on. So notice the pattern here. When you take the square root of x to a power, you get x to basically half of that power. You divide the exponent by 2. And a couple little nitpicks regarding negatives. The square root of 49 is 7. That's the principal square root. If we wanted the negative square root, we would stick a negative sign in front of the radical sign. Negative square root of 49 would be negative 7. If we had the negative sign as part of the radicand, so that it says the square root of negative 49, Well, that's just not a real number. There is no positive or negative number that you can multiply times itself that you can square and end up with negative 49. So depending on the context, if you had something like the square root of negative 49, you would either just say, we can't do that, or you would introduce the so-called imaginary numbers, which is all I'm going to say about that right now, but we will come back to the imaginary numbers and the complex numbers later on. And my other nitpick is, here I said that the square root of x squared is x, but that's not necessarily exactly true. What if x stood for the number negative 10? In that case, x squared would be negative 10 times negative 10, which would be 100. And then if we took the square root of that, we would get not the negative 10 that we started with, but 10. So in a case like that, if x stood for a negative number, squaring and then taking the square root would kill off the negative, and we would be left with the absolute value of x. So if you're dealing with a situation where x could be negative, and you have to be really careful about what that does, then you might have to say not just the square root of x squared is x, you'd have to say the square root of x squared is the absolute value of x. Now, we're not going to worry too much about that. Some of the homework problems will say something like assume all variables represent positive numbers or something like that, which means you don't have to worry about this. But there are certain situations where you do have to worry about that. So just be aware of that. And now here are some examples of other kinds of roots, not just square roots, but cube roots. 2 cubed is 8, so the cube root of 8 is 2. Negative 4 cubed is negative 64. Notice a negative times a negative times a negative comes out negative. So the cube root of negative 64 would be negative 4. You can take the cube root of a negative number and the result is negative. 3 to the 4th power, 3 times 3 times 3 times 3 is 81. So the 4th root of 81 is 3. And look at some of these variables. X squared cubed would be x to the 6th. So the cube root of x to the 6th would be x squared. The cube root of x to the 9th would be x to the 3rd. The cube root of x to the 12th would be x to the 4th. The 4th root of x to the 40th would be x to the 10th. Notice the pattern? And if you look in the book, you will find this list of properties of radicals. Some things that are true about how radicals work. For example, the square root, or any other kind of root, as long as you're consistent, of one thing times the square root of another thing is equal to the square root of the two things multiplied together. So like the square root of 5 times the square root of 7 would equal the square root of 35. So make sure you know what is and is not true when you're working with radicals, so that you know what you can and can't do. Now, I'm going to end this video here and then come back in the next video, the next part of my coverage of section P2, and we'll do some simplifying of radical expressions, which is one thing that you need to know how to do.